for number 10, more of the same stuff. Now that doesn't, we're purposefully picking out problems that have even roots and fractions, right? To kind of get you familiar with problems with the domain. But there are other things that can restrict a domain, all right? So, for example, if I take the natural log of x minus 1, can we take the natural log of 0? Can we? Can we take the natural log of 1? I can't remember. There's one of those numbers where we get it gets a little goofy. So let's try that. Let's do the natural log.
Not possible.
Let's do the natural log of 1. That's 0. Okay, that works good. But what about the natural log of 0? Uh-oh.
Wait, why would you have to do natural log of 0 if your x is equal?
But what if x equaled negative 1? Okay, so there's another domain restriction. Oh man, that's 3 things I have to memorize. That's okay though. So what we want to do is, we may not remember that, right? We might forget. Even Mr. Adams had to think about it for a second. So what could I do? Graph it. So what I'm going to do is I'm just going to graph this thing and then look at it and then kind of go back and reflect and try to understand why. So if I were to say the natural log of x plus 1 minus, and I'm just going to look at the graph. It looks like it stops here. I could also look at the table of values and see what's going on. Define, 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 define. Uh-oh, at negative 1 I have a problem. I could zoom in closer, both in the table of values and on the graph, to figure out where the problem is. But Mr. Adams remembers that you can't take the natural log of 0, right? You can't do it. And so when x equals negative 1, the stuff inside the parentheses is 0. So how would you write that?
Wouldn't there be like a limit at 0?
So now here's the thing. This is the technicality thing that I was talking about in example number 3 with the student from second hour. What is the domain then of this function? Yeah, so what's the lower boundary?
0.
Well, because of this, though, it'd have to be negative 1.
Oh, they can't go to negative 1.
Yeah, that's why I wrote the parentheses. Yeah. So this is the domain of the function. Okay? And so let's look at that for a second. So I kind of confused you guys a little bit. What I said is that f of x, if we think about the natural log of x, right? I cannot, this is not defined. I can't get a value of the natural log of 0, right? So if I plug in a 0, it doesn't exist. So basically what I'm saying, and it can't go below 0 either. And for time's sake, if you guys want, maybe when I'm done with this example, we could go back and look at what the natural log is. It's the logarithmic function with the base e. And so e's raised to a number, and we'll talk about why I have to have something greater than 0 for the natural log. Okay? We'll talk about that. But for right now, what I have to keep in mind is this stuff inside the parentheses has to be greater than 0. So I would say algebraically x plus 1 has to be greater than 0. And so I'd say x has to be greater than negative 1. And that's where we get the domain. Now technically it's continuous across the domain. Right? According to the formal definition, it's continuous across the domain because this is the domain of the function. Right? So if I were to say to you, is this a continuous function, what are you supposed to say? Yeah.
Yes.
Yes. Because we've defined the domain from going from negative 1 to positive infinity. However,
Shouldn't that be greater than or
If,
X plus.
No, because we can't include one.
if, you had the natural log of 0, it would be discontinuous.
Yes, and that was the point that I'm getting at. If we were somewhere in our homework asked to evaluate this function, take a limit, take a derivative, blah, whatever, and they said as x approaches -2, we can't.
It's already a log.
Right? Like we could plug this into that formal definition and we can crank through a bunch of math, but at the end it'll be a waste of time. So when we do a calculus problem, what we want to do is the first thing we want to check is what is its domain, what restricts its domain, and then we concern ourselves with continuity and discontinuity, because all of this derivative business is based on that formal definition. Do you guys remember? F of x plus h minus f of x as h approaches 0. That's a two-sided limit. Okay, and so we'll expand on that a little more, and we'll do more with limits and derivatives, but the first thing we need to do is determine if the function's continuous at around that point C, whatever we arbitrarily choose. So if in the textbook, and there will be one question, and I don't know, well, I know why they do it, but there will be at least one question where they're going to ask you to do some calculus work where the function's discontinuous. And if you're not careful, you'll sit there for 15 minutes trying to crank through and get the answer, and in reality, there is no answer to get, right? Because it's discontinuous at that value. Does that make sense? That's why we're spending all this time trying to determine if something